Google's quantum AI scanned 3I-ATLAS images and the results are nothing short of terrifying. When Google's quantum AI got its hands on telescope images of the mysterious object racing toward Earth, nobody expected what came next. The advanced AI systems designed to spot patterns humans miss started flagging something deeply unsettling in the data. What should have been routine analysis of another space rock turned into something that has astronomers quietly concerned. The readout suggests we're not looking at your typical comet. And if the AI is right, we might want to start paying very close attention to our unexpected visitor, the discovery that changed everything. July 1st started like any other day for astronomers in Chile. But what they discovered that morning would send shock waves through the entire scientific community. Hidden among the data from the robotic 3I-ATLAS telescope was something that shouldn't exist. A tiny glowing dot racing through space at impossible speeds. This wasn't just another asteroid or comet drifting through our cosmic neighborhood. This was something from beyond our solar system, and it was heading straight for us. The object appeared as nothing more than a speck of light against the backdrop of distant stars. But what made scientists drop their coffee cups was the speed. This thing was moving at over 130,000 miles per hour, covering distance so fast it could travel from New York to Los Angeles in just over a minute. To put that in perspective, a commercial airliner takes about 6 hours to make that same journey. But this mysterious visitor could do it in 67 seconds flat. Within 24 hours, NASA's best minds were running calculations around the clock. And what they found confirmed everyone's wildest fears and hopes. The object had indeed arrived from interstellar space, from somewhere among the stars beyond our solar system. At the moment they spotted it, this cosmic wanderer was already within Jupiter's orbit, roughly 327 million miles from Earth. But by the time you're hearing about this story, it has already covered much of that distance and is now approaching Mars. The scientific community gave it a name that reflected both its origin and its significance: 3I-ATLAS. The number 3 indicated this was only the third interstellar object ever recorded in human history, following the mysterious Oumuamua in 2017 and comet 2I Borisov in 2019. But unlike its predecessors, this new arrival was bringing with it questions that kept astronomers awake at night and had some of them wondering if we were witnessing humanity's first contact with alien technology. What made this discovery even more unsettling was how late we spotted it. The object had emerged from a particularly bright region of our galaxy where the dense concentration of stars had masked its approach for years. By the time we noticed it, there wasn't enough time to prepare a proper scientific mission to intercept it. It was almost as if something didn't want us to see it coming until it was too late to do anything about it. A speed and size that defied all logic. When scientists first calculated the true dimensions of 3I-ATLAS, the numbers seemed so outrageous they double-checked their math multiple times. While Oumuamua had been roughly the size of a football field at about 330 to 380 feet long, this new visitor was hundreds of times larger. Early estimates suggested its diameter could reach 6 to 9 miles across, making it comparable to the size of Manhattan Island. Imagine the entire island of Manhattan hurtling through space at 36 miles per second, and you begin to understand why this discovery kept scientists up at night. The speed alone was mind-bending. At 36 miles per second, 3I-ATLAS was moving so fast that even the sun's immense gravitational pull couldn't capture it and keep it in our solar system. This velocity was roughly twice as fast as most known objects that call our solar system home. For comparison, one of humanity's fastest spacecraft would look like it was standing still next to this interstellar speed demon. But size and speed were just the beginning of the mystery. The object's trajectory through space seemed to follow an impossible path that had astronomers scratching their heads and checking their calculations over and over again. Most objects from interstellar space follow predictable paths based on gravitational influences and momentum. They typically zoom past us in relatively straight lines, maybe getting pulled slightly by the sun's gravity before heading back out into the cosmic void. 3I-ATLAS was doing something completely different. The path it was following would take it on a grand tour of our solar system's inner planets. First, it would pass within 17.5 million miles of Mars on October 2nd. In cosmic terms, that's practically a close encounter. Then it would reach its closest approach to Earth on December 19 at about 167 million miles away. After that, it would swing by Venus at just 60 million miles and finally make a return pass by Jupiter at only 33 million miles from the gas giant in 2026. What made this trajectory so extraordinary was the mathematical probability of it happening by chance. Scientists calculated that the likelihood of an interstellar object naturally following such a perfectly aligned route with multiple close planetary encounters was less than 0.005%. In other words, in 99.995% of cases, a random interstellar visitor would just zoom past without coming close to any planets at all. The fact that 3I-ATLAS seemed to be following a deliberate path that would give it front-row seats to observe multiple worlds in our solar system was enough to make even the most skeptical scientists wonder if they were looking at something artificial. A trajectory that seemed too perfect. Harvard astronomy professor Avi Loeb and his colleagues spent weeks analyzing every aspect of 3I-ATLAS's flight path. And what they discovered sent chills down their spines. This wasn't just any trajectory. It was what space mission planners would call a perfect grand tour route. If human scientists were designing a probe to study as many planets as possible in our solar system, they might choose a path very similar to what this object was following. The precision was unsettling. 3I-ATLAS would pass close enough to Mars to conduct detailed observations, then sweep by Earth at a distance that would allow comprehensive scanning while remaining safely out of reach. The Venus flyby would bring it even closer to that world, and the final Jupiter encounter would provide a gravitational slingshot that could potentially alter its course if needed. It was like watching a perfectly choreographed cosmic ballet, except no one had written the choreography. What made Loeb and his team even more suspicious was the timing of Earth's closest approach. When 3I-ATLAS reaches its nearest point to our planet on December 19, it will be positioned on the opposite side of the Sun from Earth's perspective. This means that while the object will be perfectly illuminated by sunlight, making it ideal for observation, the Sun will be directly between us and the visitor, making it nearly impossible for us to study it in detail. Loeb suggested this might not be coincidence but deliberate planning a way to observe us while avoiding our scrutiny. The possibility that this trajectory was intentionally designed raised even more disturbing questions. If 3I-ATLAS was indeed some form of alien probe, why wasn't Earth its primary target? After all, if the goal was to study intelligent life, wouldn't it make more sense to approach our planet as closely as possible? Instead, the object would pass nearly 10 times closer to Mars than to Earth. This led Loeb to propose a fascinating but terrifying possibility. Perhaps the visitors were specifically avoiding close contact with Earth's inhabitants while still maintaining the ability to study us from a safe distance. There was also the unsettling possibility that 3I-ATLAS had no intention of leaving our solar system at all. Using advanced gravitational maneuvers around Jupiter or the Sun, the object could potentially slow down and enter a long-term orbit that would allow extended observation of our worlds. Such techniques known as OATG effects are commonly used by human space missions to alter trajectory and speed using planetary gravity combined with propulsion systems. If an alien civilization had mastered interstellar travel, they would certainly be capable of such maneuvers. The timing of when 3I-ATLAS began its journey toward us was perhaps the most chilling detail of all. Calculations showed that at its current speed, the object would have crossed the outer boundary of our solar system approximately 8,000 years ago. That time frame coincided with a period of remarkable change on Earth, when humanity was just entering a phase of rapid development with the emergence of early civilizations, writing systems, and large settlements. The possibility that these developments had somehow attracted attention from across the stars was both thrilling and terrifying to contemplate.